Auzubillahiminash-shaytanir-rajeem. Bismillahir-rahmanir-rahim. Assalamualaikum everyone. Today's lecture is about practical of pharmaceutics, and this practical is about determination of viscosity of pharmaceutical products using Ostwald Viscometer. So, in the previous lecture, we have discussed the practical about determination of solubility of benzoic acid at different temperatures. So, but in today's video, we are going to determine the viscosity, and we use a specific instrument for the measurement of viscosity, which is Ostwald Viscometer. You know very well, viscometer is a device which is used to measure the viscosity. So Ostwald viscometer is a type of viscometer, and it is most frequently used to measure the viscosity of different pharmaceuticals products. So, first of all, we are going to discuss the aim and objective of this practical. So, the main aim is to understand the concept of rheology and the behavior of liquids. You know very well, viscosity is defined as it is the resistance in the flow of a liquid. So now you are going to understand the concept of rheology in that practical. So what is rheology? If you don't watch the video of rheology, then go visit my channel. I have made a full video on the rheology concept, so you can clear that concept from it. Now here I will define what is rheology to you. So rheology is a branch of science which is dealing with the flow of liquid, and it also used to study the deformation of solids. Okay, so now here you know very well, behavior of liquids are a study in the branch of rheology. So viscosity is also a type of material which is used in the behavior of liquids. Second main objective of this practical is to find the viscosity of different pharmaceutical products. That is very important because we prepared a lot of pharmaceuticals products, and in the production of these products, we have to calculate the viscosity of them because we have a limit range to produce a viscosity, such viscous type object. We cannot prepare more viscous type of objects such as creams and lotions, etc. So therefore viscosity determination is very important for all of us. Now we discuss the theory of that practical. First we are going to define that what is viscosity. This is the sign of viscosity by which we are going to donate it. So viscosity is the measure of resistance of a fluid which is being deformed by the shear stress. So why a fluid is being resistance? Because of a force is acting on it, and it is going to displace and its object, and it is and the viscosity is going to provide resistance in the flow of liquid. It don't allow fluids to resist and to move forward on the application of force. So viscosity actually indicating the thickness and internal friction. Okay, it is going to indicate that this fluid is very thick. For example, you see honey. Honey is a very viscous substance, and it is not going to flow easily as that of water. Water can easily flow. Okay? A small amount of force can allow water to flow out, but when you see the same force is exerting on the honey, it is not going to move at the speed of water because it is thick. It has thicky nature, it has high viscosity, and it has its internal friction, and due to this internal friction it is not going to behave like water. So therefore you see that the liquid's behavior change upon the viscosity. There is a lot of difference between the honey and the water due to this property which is called as viscosity. Now, water is thin, having low viscosity, while the honey have thick and higher viscosity. This is the example. For some fluids, viscosity is constant over a wide range of shear stress. This is called as Newtonian flow. Because in Newtonian flow, they are going to obey the Newtonian law, and their viscosity is going to remain constant over a range. From this range to this range, its viscosity is going to as a constant. But there are some fluid in that there is no constant viscosity, and these fluids can be called as non-Newtonian fluids. And examples of non-Newtonian gems are very important. For example, colloid, suspension, emulsion, that has non-Newtonian flow, while the pure liquids, water, ethanol, and etc., they are going to indicate Newtonian flow. Sorry, liquid. So, what is that? A non-Newtonian flow does not contain a constant viscosity and cannot be described by a single number. They are variable, and the non-Newtonian flow exhibits a variety of different correlation between the shear stress and shear rate. So, it has a relation between shear stress and shear rate. And one of the most important instruments for the measuring of viscosity is the Ostwald Viscometer. So now we are going to deal with that Ostwald Viscometer, and we are going to measure the viscosity of some substances. So the apparatus we need for that practical is, first of all, is the Ostwald Viscometer. Second thing is the pianometer, stopwatch, sucker, and tissue paper, which is could be called as blotting paper, graduated cylinder, beaker, pipettes, and weighing balance. And the chemicals we require for that practical are distilled water, pharmaceuticals products, and acetone. So these pharmaceuticals products are those products whose viscosity we are going to detect. So now we discuss the procedure for that experiment. So first step of this experiment is to clean and dry all the glassware which you are going to use in that practical. Second thing is you have to calibrate a weighing balance and accurate it. If it has some error in it, you have to change it or use some alternative of it. Not the weight of a dry empty piezometer. So first of all, you have to place wet and dry piezometer mean dry piezometer mean empty piezometer, and you have to place it on your weighing balance and not the weight of it. Now you have to find the volume of piezometer, so you are going to fill some water in the piezometer, and now you not the volume of it, fill it with water and not the weight and volume of the water. Now you are going to determine the weight of water. So how you determine weight of water is equal to W1 minus W of piezometer. This is a weight in which water is added in the piezometer and we weight it. So this is its weight, and W1 is the actual weight of water when we put it in graduated cylinder and we measure its weight. So calculate the density of water. You can calculate density of water as W water or V water. So mass of water divide कर देंगे आप volume of water, and you will find out the density of that water. Similarly, determine the densities of the given standard solution of dilution at 80, 60, 40, and 20%. So you are going to calculate the densities of standard solution, and these standard solution are these pharmaceutical products whose viscosity is to determine. So you are going to produce its dilution of 20% solution, 40% solution, 60% solution, 80% solution. So how you prepare these percent solution? So for example, if I have wanted to prepare 20% solution, so what you will do, you will take 20 grams of that compound and dissolve in 100 gram of water, and then you will prepare the solution. This solution is called as standard solution of that product, and it is the 20% of 20% solution of that product. Okay. So now you are going to clamp your viscometer vertically in the vertical direction, and the pipette distill water through the arms of a viscometer till above the mark C at the top of the bulb. So by pipette you will add distilled water into the viscometer and through the arm of viscometer above, and you will fill the viscometer up to the mark C, which is labeled on the viscometer. Now you draw the water up to the other arm of the tube and above the mark A. So first you fill up it above at the mark C. Now you fill it above the mark A. These markings are given on the viscometer, and I will show a diagram to you also. So now you note the time at the surface falls between the B and A. Okay, the surface of liquid which you fill up, and when it is going to reach the mark A, you will open the stopwatch and you find out the time whether which is it taking from moving mark A to mark B. Now you empty your viscometer, rise in it with small quantity of the given sample and note the time the flow from A to B. So now सबसे पहले आपने ये एक्सपेरिमेंट परफॉर्म किया वाटर के साथ, ये वाला ठीक है, डिस्टिल वाटर के साथ. अब आप करेंगे जो भी कोई भी सैंपल, द सैंपल विच यू नीड and the pharmaceutical products whose viscosity is used to determine. So then you fill it and you again note the time when this product is moved from A to B. So by comparing this time you will notice the viscosity of that substance. So you are going to repeat this procedure for 80% solution, 60% solution, 40% solution and 20% solution. You will prepare that solution and one by one you are going to detect the viscosity of these solutions, and then you will write down all of these answers to your practical book, and you are going to follow a equation for it, and this is that equation that eta s is equal to eta w ts density s tw rho water. So by putting the values in that equation you are going to find out your real answer. So this is the viscosity of water which you have must have to know. Then you will time for the substance and time for the water, so you will calculate this time by this method I explained to you. And you also know the density of that substance. So to measure the that density you will weight it, and then you will find the volume of it, then you will divide the volume, sorry, weight by volume, and then you find out the density. And similarly density of water can be calculated by it. At the last, you will draw a bar graph to compare all the viscosity of that substance, that which is most viscous and which is most least viscous, and you will define it by the graph. At the last, you will write down the precautions, and all the apparatus should be clean. You should calibrate the weighing balance before use. Keep the Ostwald meter in the vertical position, that is really important. Rise the piezometer with acetone and dry it, and you should be careful that no drop of acetone should be present in piezometer. Now we move on to the calculations and we see what are the values of viscosity of different pharmaceuticals product which we are going to choose. So this is the pencil work of our experiment, and this is the diagram of Ostwald Viscometer, and I have explained to you that it has three marking A, B and this C. So first you are going to put water from this arm, and you are going to fill it up to the mark C. So then you will find out the volume and weight of that water, and at the last after measuring then you will see you will have to take water above the mark A. When it reach above the mark A, slowly it will be come down. So when it is move down from here, when it reach at the point A, you will start the stopwatch, and you will notice the time when the fluid take times from moving from this point to this point. And similarly you will take the product, the pharmaceuticals product whose viscosity is our main desire, and you will take the similar procedure for that compound. So here is the important table in which some substances and its viscosity are given. So for example acetone viscosity is 0.306, and the viscosity of ethyl alcohol is 1.074. Viscosity of ethylene glycol is 16.1. Olive oil is 81. Castor oil is 98.5, and glycerol is 1200. So these are some viscosities which are given to you. Now we move on to the next page. Here a table is given to you, and in that table it is explaining the effect of temperature on the viscosity. So you see here the temperature increases from 10 degree to 100 degree centigrade, and this is the viscosity, and you can see the relation of temperature and viscosity, and you can find out how temperature can affect the viscosity of a particular substance. Now you are going to discuss the observation and calculations, and we are going to calculate a viscosity. You should have to keep the temperature at the room temperature. That is very important because your temperature is going to change your viscosity. You should, before performing that experiment, you should notice that the temperature at which you are going to perform this experiment should be 25. And the volume of physometer, you will find out the volume of physometer, it would come out 25 ml. You will weight it at by placing it on the weighing balance, and its weight is come out by this value. Then you find out the weight of physometer and water, so you are going to minus that substance weight, and you find out the real answer. Then you find out the density of your water by dividing the weight of water by the volume of water, and you will get the density and the flow of time of water. And you also have to find out it because have to measure the time, whether when the water takes from moving A to B. So this time is 5 seconds. So now the first pharmaceutical product we are given to you is the 30% ethanol. So you have to find out the viscosity for it. So first you have to prepare the 30% of ethanol, and then you will weigh the mass of it. So the mass of 30% ethanol is this. So then you find out the density of it by dividing the mass by the volume of this 30% ethanol, and you will find out the density of that compound. So at the last, you have to put all the values in that formula to calculate the final viscosity. So the viscosity of water is 0.01, and the time taken for that substance come out 6 seconds. Water has 5 seconds take to move from A to B, and that ethanol take 6 seconds to move from A to B. So here you can find out that ethanol is more viscous than the water, and the density of that substance is 0.95, and the density of water is 1. So by putting all these value, multiply and divide them, and you get the final answer, that is 0.0114. So this is the viscosity of 30% ethanol. Now you calculate the viscosity for the 20%, for 60%, for 80%, but whatever it is, you can calculate this viscosity by this formula. Put all the values in that formula, multiply and divide them, and you will get your final answer. So I hope that you will understand this video, and please subscribe to my channel, like my videos. If you have some question, then comment me in the comment section. I will give answer to you. Take care of yourself. Allah Hafiz.